Welcome back to the automotive session of the VIP stage here at the booth of WK Fachmedien. I have my next speaker here with me, or my next interview partner, better to say. It's Dr. Nigel Tracey from ETAS, which is a subsidiary of Bosch. And he's based in York in the UK, but he found the way across the channel to come to us, to Nuremberg. And we are talking about focus on functional safety and security. Nigel, why is it not possible to separate the two aspects of safety and security in a vehicle?
Okay, that's a good question. So I think first, safety and security are both systems properties of the vehicle. So you have to consider both, put in the context of the vehicle that you're talking about. And safety is really the focus on making sure the system you're building is free from systematic errors and random failures that might occur in the hardware. Security is somewhat similar, only it's really about protecting the system against malicious attack. But in many ways, they're kind of the same property to look at. A systematic failure or a random failure, in its worst case, is very similar to a systematic, carefully crafted vulnerability or attack in the system. It makes the system fail in a very similar way. So I think to put the question, or the answer to the question very shortly, of course, if you want to argue a system's safe, then you need to reason a lot that your system is free from these systematic and random failures. If you put all that time and effort into the software and system design, then it's very important to know that the system that is free from those errors is exactly the system that's still running. And this you can only do if the system's secure. Otherwise, someone may have changed it or compromised it in some way. Then you can't reason anymore about the safety of the system. Because at that point, maybe you're not running the system that you've already argued is safe. So because the properties are so interlinked like this, you really can't have safety without security. Because if someone can change your system, immediately it's potentially no longer safe. And therefore, if you want to be confident in safety, you must know that the system you've argued is safe is secure, so it can't be changed, can't be manipulated, can't be changed and compromised. So for this reason, I think you have to do both things together. Both things have to be taken at the system level, and both have to go through the life cycle of the vehicle. So for this reason, they're closely intertwined from my perspective.
So if both can't be differentiated, so how can the topics of safety and security be addressed in a holistic manner?
So I think because they're systems properties, it's necessary to reason about them holistically in the system context. No piece of software is dangerous. It's not until you put it in a system that's moving that it suddenly becomes potentially dangerous. So for this reason, you have to address a property like safety holistically. But also security is somewhat similar. No system is necessarily secure or insecure until it's in the context of its environment, its interaction with the other systems. Therefore, the two are interlinked in this way, and it's very, very necessary to work on them here, then holistically together. I think also, of course, once you put the two things together and work across the life cycle of the car, it's important to know that the car is still safe post-production, post-maintenance, and the same with security. As you do updates or fixes to the car, for this reason you have to address the properties really together. And both of the properties are really about risk management. I mean, there's no guarantees with either of them. Therefore, both of them are about managing risk, putting in place processes, mechanisms, validation and verification processes to show that you've reduced this risk to a comfortable level. And therefore, the kind of approaches you take are somewhat similar. Although the language spoken by the safety and security community are often a little bit different, the processes of mitigating risk, managing a risk, are basically the same. You break down from a security goal or a safety goal down to mitigation measures. Therefore, you're following the same kind of risk management approach with both properties throughout the development of the system.
Safety and security so far is perceived as a kind of given, but do not represent a marketable function or feature. Even whereas both are regarded as cost factors. How do you deal with this problem?
So, I mean, I'm not sure that they're pure hygiene factors. I mean, there's certainly OEMs that market their vehicle on safety. Now, it's very often the vehicle safety in terms of how it performs in a crash or how it drives, but I think functional safety is part of that. And functional safety enables many of those safety properties. So I think what you're starting to see is in some cases, it can be more than a pure hygiene factor. It can be something with some value. But again, as I said in the last question, I think it's mostly about risk management. And the costs of problems are so high. The costs of, if you have a safety problem, or you have a security problem, of fixing this, and the brand damage that can be caused from this are so high that while they might not be directly marketable functions, they argue their own case in terms of the investment, in that if you don't do it, you're taking a huge risk of liability, of recall costs, of fixing costs on your shoulders. And that's the trade-off. Do you manage that through good engineering up front to mitigate these risks? Or do you take it later and take the risk that this is then going to cost you a lot of money to retrospectively put it right? And the brand damage caused by a safety or security vulnerability is enormous. So these things, I think, normally mean that they're worth to invest in. But when you look at other industries as well, if you look at rail, nuclear, or aerospace, then safety there is also a hygiene factor. But it also more and more becomes something that's necessary in order to get the system released. And I think this is happening more and more in the automotive industry as well. You will not be able to put a system into production unless you can argue that it's meeting the regulatory requirements of being safe and secure. And we're seeing this more and more, and I think this will increase more and more, especially with levels of autonomous driving increasing or driver assistance increasing. This will mean the regulatory hurdle to prove that you've taken reasonable engineering best practice to cross that hurdle of having a safe and secure system. Will make it mandatory. You don't talk in an aeroplane, is it worth to invest in safety? If you don't get to put the aircraft into the sky. So I think more and more this will happen in automotive as well. ISO 26262 already starts this. If you can't show you followed what is considered state-of-the-art best practice, then you take a huge liability burden if there's ever a problem. So if you don't follow the standard and then you have a problem, you lose a lot of your argument in any court case that you followed engineering best practice. So for these reasons, I think you're seeing more and more this acceptance that this is a cost that must be invested in order to manage the risk, in order to meet the growing regulatory requirements, and in order to show you followed best practice.
What role do certifications play in this context?
So I mentioned one standard, for example, ISO 26262. That's a standard for which you can be certified to show you follow. There's the common criteria for security and other security standards as well. I think in general, certifications and development standards, process standards, are a little bit a double-edged sword. In many ways, they're really great because they embody best practice. They talk about the methodology and mechanisms you should deploy. They help you decide which kind of engineering methodology is a good one to use in certain circumstances. That's where they're very positive. It enables this best practice sharing. It enables really everyone to have a consistent best way of following these things. But it can also, as I said, be a double-edged sword that sometimes the real goal can get lost. And you start as in an engineering team to start to think your job is to fulfill the development standard. Your job is to comply with ISO 26262 and not to build a safe system, but to follow the standard. That's where I think it's important to have the right culture inside your development organization and your company, because if you have that mindset that your job is to tick the boxes from the process standard and to achieve just the certification, you can end up doing a lot of busy work. So I see this a lot, for example, with things like test coverage. Most of the safety standards say you should do enough testing to check that you've achieved a certain level of coverage of the software, that you've got test cases to go down all the different branches of the software, for example. What I see very often is that becomes a goal to get 100% coverage. Not to check that they're good test cases and that the test cases are passing properly, but just to test that you can create them and go down all the paths. Now that's when the standard's fighting against safety, because instead of doing the right job for safety and focusing on the goal, which is to build a safe and secure system, you're focusing on ticking the box in the standard. So I think you have to be careful. I think in general they're a very, very positive thing to ensure high levels of best practice, high levels of consistency across the industry, but you need the right culture to adopt them in your company. It can be very dangerous if the goal becomes to fulfill the standard rather than to do the good engineering job.
Are there any specific challenges which does the automotive industry still have to overcome in terms of safety and security? Maybe AI problems?
Yeah, I think there's quite a lot of challenges. So first, I would say the culture one is a big one, especially around safety. Mm-hmm. That system safety culture that is deeply embodied in the nuclear industry, the railway industry, and the aviation industry is really just starting in automotive. That kind of systems engineering approach that goes through the OEM to the tier one down to all the suppliers is something where there needs to be still further development. I mean, it's much less mature in automotive compared to aviation, which has been developing this culture for the last 50 years. So I think there's a long way to go on that culture, to investigate every accident, to find every root cause, to ask why it happened 5 times to find out all the contributing factors, and to take that into all future designs. That works really fantastically in industries with very high safety cultures, like the nuclear industry, the rail industry, or the aviation. The automotive industry still has some way to go here. You also mentioned another huge challenge right now, which is AI or more heuristic type systems. So AI or search-based systems. These are a huge challenge from safety, because most of our mechanisms for reasoning about safety apply to much more classic types of systems and software. And to argue and reason that a neural network is somehow performant enough to then go into production and doesn't have some very strange systematic failure is something that's really state of the art in research at the moment and making progress, but there's a lot more to do. So I think this is a really big challenge for the future for automotive, because these systems are rapidly becoming deployed in more and more of the car systems and are very important for achieving the goal of higher levels of autonomy. So we need to know that these systems are safe and secure. They're not vulnerable to simple failure modes. There's been some interesting research out of the universities that show that making just small changes to road signs, just putting a sticker in the corner, can cause the AI system to completely fail to recognize the road sign. These are, of course, unacceptable when you care about safety of an autonomously driving car. So we need stronger, more robust ways. Things like ISO 26262 don't really give us yet the tools to reason about neural networks and AI-based systems. So this is a big challenge along with the culture for the future, I would say.
So thanks a lot, Nigel, for the insights into the safety and security challenge. It was really great to have you here. Thanks for coming, and enjoy the show.
Yeah, thank you very much. Thanks for the opportunity.